Welcome to Academic Daddy's class. So what we are doing today is plane geometry. We know we have coordinate geometry and plane geometry. So what we are doing today is plane geometry. We say that geometry is the study of line. We say is the study geometry. Let's put it this way. Is the study of linear and angular measurements, shapes and figures bounded by lines and curves. So whenever you are looking at something like those shapes that make up 2D, and you know that from there you can transfer it to 3D. Let's say you see the head of someone and say this head is circular. You are trying to mirror it down to two dimensionals, a situation where the person can easily understand it. So geometry talks about shapes and figures, and you know that majority of things you have, everything you have is either a line or a curve, or a curve and a line. So if we know this, that means that in geometry we are going to be looking at lines, then we're going to be looking at angles whenever two or more lines meet, or whenever two lines meet it forms an angle. So from angles we'll do triangles, if time permits us we'll do circles. So circle theory. So now first of all, kinds of lines. You know, in secondary school those days, teachers will come and tell you we have zigzag lines. They tell you things like this: zigzag lines. This is not true, because this is a line. This is another line. This type of line, this is an oblong line or oblique line. This is also an oblique line. So there is nothing like zigzag line. It's a shape. So it's just that they are trying to tell you, use it to describe. So the first one, let me start with this oblique lines. So we say that when a line is at an angle, like, or let's say it goes this way or it goes this way, or it goes this way. So any line at an angle, any line at an angle, or at a line at any given angle, or any line at a given angle is said to be oblique. So provided the line is not provided the line is not horizontal and is not vertical, is called oblique line. The second type of line is what we call vertical lines. So we say that there are lines that start, or you say first of all, line is the extension of a dot, or you say lines are angles at 180 degrees at zero. Lines are angles from 0 to 180 degrees, or you say they are extension of a dot. So when this dot extension runs from top to bottom or from bottom to top, we say that they are vertical lines. So vertical lines are lines that are at 90, or should I say, I don't want to say 90 degrees, but because lines at 90 degrees have a name. So lines at 90 degrees, they are called perpendicular lines. So let's put it this way. So they are just lines drawn from top to bottom, or from bottom to top. So number 3 is horizontal line. So we can say they are extension of dots from left to right, or from right to left. It's the same thing. So now fourth one, perpendicular line. So we say that perpendicular lines are lines at 90 degrees. And we say that perpendicular lines are lines gotten when two lines meet. So we say that there are lines gotten when the vertical and horizontal line intersect. So at the point of intersection, you get 90 degrees. So whenever a line is gotten by joining vertical and horizontal, we say that they are perpendicular lines. The fifth one is what we call parallel lines. So we say that parallel lines are lines that will never meet. It's just like when you tell somebody, you and sense, you people are parallel lines. So you are saying that they can never meet. So parallel lines are lines that can never meet. So if I have maybe a line like this vertical, or if you don't want to put it like this, you say two or more horizontal lines are parallel. Two or more vertical lines are parallel. Two or more oblique lines are parallel. So when I have a horizontal line, as many as they can never meet. When I have vertical lines, they can never meet. When I have oblique lines, they can never meet. So we say that they are parallel. Now the sixth one is what we call transverse line. So we say that transverse line is transverse line is a line that cuts a parallel line, or we say transverse lines are lines that cut through the parallel line or the parallel lines. So if I have a parallel line like this and I have another line cut through it, that's a transverse line. This line here is a transverse line. So if I have maybe something like this, horizontals, and I come and have another one like this, the line cutting a parallel line is a transverse line. And you see that this is now a parallel line. These two are parallel. So we can say either this is a transverse, either these two are transverse to this line, or this line is transverse to this. So when two lines cut through each other, they are transverse. That's what I mean. So if we've noted this, let's now look at the properties of lines. You see, properties of a line, whichever way you want to put it, but you can't just have properties of a line. So it will be properties of lines. So because line on its own does not do anything, just to maintain a position or to show displacement. So when I have maybe, let me do it here. Okay, let's just continue. Next I have, no, I want to do it in a place where I can easily flip. The properties of lines. So we can say transverse line, parallel line, or whatever. So if I have, for example, something like this to be a line, and I have transverse line cutting through it, need to get 10. This one is misbehaving. So if I have this, let's say I call here A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So now that you have this, you need to know properties of line. Now notice something. The first property I always advise my students to take note of is what we call adjacent line. Notice on this line, just this top part, if I have this and I have this top part, I have A, B, C, D. Notice that this line forms an angle, and this angle is close to this. So we say that the first property I want you to take note of is adjacent angles, or you say adjacent lines. So yes, so adjacent angles. I want to use adjacent angles. So first of all, we say that adjacent angles are angles next to each other. So you can see that A is adjacent to C. A is adjacent to C. And these adjacent angles make 180. Reason being that, look at this. This is a straight line. And angles, this is for angles. Angles on a straight line equals 180 degrees. So the first property of a line, from what we've drawn is that lines form angles. lines form angles. So lines form angles, and the angles formed by a line have these properties. So this is A is adjacent, and that means that because A is adjacent to C, means that if I add A and C, I will get a straight line. So A plus C equals to 180 degrees. So we call this allied or adjacent angles are supplementary. They are supplementary. Supplementary means when two angles. Supplementary means when two angles add up to 180 degrees. I normally use supplement. If you want to write 8 now, you have S like this, and inside 180 you have 8. So supplementary. While if I have, when I start doing perpendicular, so for perpendicular lines, so when I have two angles, two angles adding up to 90 degrees. See, if I want to write 90, I will do my hand like this, then do like this. So complementary angles. So complementary angles equals when two angles add up to 90 degrees. So notice, like all these things are just for you to note. So let's continue. But notice A and C are supplementary. That means if you check, this is also another straight line here. So A and B, A plus B can add up to 180 degrees as well. The same reason, allied and adjacent angles are equal. Now notice again, B and D, this B and this D can add up. So B plus D can be equals to 180 degrees. Now notice something. This D and this C are on this straight line. So C plus D equals to 180 degrees. C comes before D in the alphabet. So now that I've noted it, that's the first. So you can use the same approach here. E and F are adjacent. E and G are adjacent. G and H are adjacent. H and F are adjacent. So you can use the same approach. So under the comment section, find me all the adjacent angles for the top transverse line and for the bottom transverse line. So on the call to action on the comment section, to write out the remaining adjacent angles remaining. Put it in the comment section. I will mark it there. I'll notify good or bad there. So now the next property of angle or formed by a line. So the next property is simply, notice something here. This E, okay, let me use this part. Let me bring it out again. Looking at this. Let me bring it out. So I have A, B, C, D. I have E, F, G, H. Notice that this E and H, they are facing each other. This F and G, they are facing each other. So we can say that E is equals to F. And so E is equals to H. What are you doing? E is equals to H, and F is equals to G. Reason is that whenever something is facing the other one like this, or like it's like this, because see, this thing like this is directly. This is directly. So whenever something is facing something directly, we say that they are vertically, or you say it, or directly opposite angles are equal. So if you know this, find me the vertically opposite angles here. So the next property is alternate angles. are equal. Alternate angles. So let me draw that again. I have this, and I have A, B, C, D, E, F, G, H. Notice something. This E is like is opposite this. They are facing each other but at an angle. While this G is facing this at an angle. So see what it means. If I have my left hand like this, by the time I come and place the right one, the thumb will be on this side, this other thumb will be on this side for it to be facing. So it's just the same approach. If I have this up here, it means that this same angle here is also down. So if I have, it's the same approach I normally teach my students. If I have, for example, let's say I have a here. See, let's say I have something like this, and I have something like this. Notice that the line here extends to meet this. So they are the same. So if I have to flip this thing now, this particular side is the one that is here. So if I have A here, that is when this thing is lying down. If it has to stand up, this A will be here. If I have B here, notice that this is here. So it's here. So B will be here. So that same approach, if I have this up here, it will be also here. So we'll solve examples so that you see what it means. So if I have that, notice that for the fact that this is here, this is here. For the fact that this is here, this is here. So I can easily say that B is equals to G and D is equals to E. So we say that they are alternate angles. Alternate angles are equal. So anytime something is opposite the other, so when something is opposite to the other at an angle, or you say when the same line extends from left to right angle. So notice that on this part is like top. Let's say this is top left and here is down right. So however you want to view it, but when you start solving examples, you see it. So the next one, for internal angles equals 180 degrees, external angles equals 180 degrees. This is the shortcut of everything you are doing in geometry. If I have this, and I have this, and I have, for example, let's say they give me here 80, and they give me here 100. Automatically, let's say I now call here E, G, H, sorry, yes, okay, sorry, let's say I call this N, P, M, O, and let's say I call here A, B, C, D, I, J, K, L. If I have this, that's the way I have it now, without solving anything. Since I am giving the external on the right, look at the external on the left. These two should add up. So A will be automatically equals to 100. External angles are equal. Why? A should be the same thing as saying A plus 80 will be equals to 180 degrees because they are external angles here. So that means that I should be 80 because I should be 80 because if I do I plus 100, it will be equals to 180 degrees. So that I will be equals to 180 minus 100. I equals to 80 degrees. Now somebody wants to ask me what of the internal. To find the internal now, remember that we said that this place is H. Now notice something. 80 is directly opposite to G. So that means that G here is equals to 80 degrees. And if G is equals to 80 degrees, see what I mean? Yes, now vertically opposite. If G now is equals to 80 degrees, if G is equals to 80 degrees and this is equals to 80 degrees, automatically this angle, this D, will be equals to 100. Now, if that is true, notice that this G that is 80, this G that is 80 degrees, is alternate to B, so that means that B will also be 80. B will also be 80 degrees. B will also be 80 degrees. And notice something. If B is 80 degrees, remember that B is adjacent to A, and the adjacent angles must add up to 180. So if you see it, you see that this is 100 remaining. And remember that A is 100. So without solving anything about angles, you look at it, you know it. So now notice, if that is true, that means that since here is 100, without even solving for this part, since here is 100 and is a straight line, that means that this side, angles on a straight line, should be 8 degrees. And if this is 80 degrees, the internal angles of any line or any, yes, the internal angles of any parallel line or any line, any setup, should be equals to 180. So since this is 80, here should be 100 automatically to add up. And if this is 100, notice adjacent, so they are close to each other. So that means 100, this should be 80 degrees. And notice 100 external, 180 external, 100 plus 80 is 180. So note that. That's a shortcut. When you know this, you don't need to solve anything about this. So the fifth property, corresponding angles are equal. So let's say I have this and I have this and I have this and I have this. I want to maintain, so A, B, C, D, E, okay, A, B, C, D, E, F, G, H, I, J, K, L, M. So see, corresponding, whenever you hear correspondence, corresponding means the same position. A here, notice that this A here, if I redraw this side, this is A. Now let's say I come here and redraw this. If I redraw this, this is E, this side. So they are having the same position. So A is equals to E. Now notice, if I have F here, this is F. So F, sorry, yes, this is F, this is B. If I have B, sorry, if I have B here, the way it is, this is F. So B is equals to F. Now this is where C is. This is where G is. So C is equals to G. This is where D is. This is where H is. So G is equals to H. Why? They are corresponding angles. So using the same approach, I will say corresponding angles are equal. Now using the same approach, find me the corresponding angle. Okay. IJK, L, M, rush 1 Q, M, N, O, P. So find me the corresponding angles here. So if you do that, I want to believe that we can now take an example. So let's say we have an example question given to us. Let's say we have an example question given to us, and they say we are given so let's say they call here 57 degrees and they call here 123 degrees. Let's say they call here anything they call it. They ask us to find this angle A, B, C, D. E, F, G, H, I, J, K, L, M, N, O. So they tell us to find all the alphabets lettered, the missing angles, that we should find it. So in order to find it without stressing, all I will need to do is to say this angle here is correspondence to this. D is 57 degrees. They are in the same position. This angle here is correspondence to this. I can start from anyhow I want it. This is 123 degrees. So if I know it without stressing myself, this is external. 123 plus 57 is equals to 180 degrees. This side, this is the outer part of this side up here. Down here, there is for the up transverse. That is, this is the outer part of this. So 57 plus what? 123 will add up to 180. If that is true, if this is 123, this side should be 57. Edge here will be 57. And if that is true, vertically opposite, this will be 123. Vertically opposite, this will be 57 degrees. Vertically opposite, 123. If this is 123, now notice outside, I don't want to use, I have many methods on those properties, but I'm just using the one that makes it shorter. Now this is outside here, and this is the outside of this part. This is 123. This should be 57, so that external angles will add up to 180 degrees. Now notice this is internal to this. So internal should add up to 180 degrees. That means 57 is remaining. If you don't want to do it like that, notice that this is vertically opposite to this. So this should be 57 degrees. Now, this is 57 here. Internal. Internal means what is closed inside should add up to 180 degrees. So this should be 123. If you don't want to do it like that, you can say adjacent. Everything here is 180. 180 minus 57 should be 123. So it's still the same thing. Or you say corresponding. This angle here is the same angle here. So it's 123. Vertically opposite. This should be 57 degrees. Vertically opposite. This should be 57 degrees. If that is, what are you doing? Vertically opposite. This should be 123. What are you doing? That is looking here. So if you know that, notice that this 123, this position is the position here, 123. Or you see vertically opposite, or you see they are on a straight line. 180 minus 57 will give you this. So vertically opposite, 57 degrees. So let's take another example. Let's say I have I now have an angle 55 degrees. Then let's say I have P here, and I have R, I have T, I have S, I have Q. Then whenever, also you need to note that anything that has to do with lines and angles, if they are the same, you show it with, for example, see what I mean. If I have two lines like this and I have another one like this, if I want to show that these two are parallel, this is parallel to that, so I just put something like this. Then I will now show this one that they are parallel with two, like a different arrow. So the arrows should be different to indicate the difference in the direction of your lines or angles. For example, if I have an angle made, and I want to show it, I can show that this angle, and let's say there's another one made inside here. I can show that this angle is like this, and then I want to show that this angle is different. I can show this one by doing this arrow. Notice this is 2 and this is 2. So this 2 means that this angle is the same with this angle. While this one that has just 1 here means that this angle is different. So you indicate angles or lines, angles formed by lines with whatever symbol you can use, or like arcs, to show the difference. So now in this question, they are asking us in this figure to find the missing angle, angles. So let's say we know that this angle and this angle are the same. Then So let's say this tell us find the missing angles. So in order to find the missing angles, all I need to do is to simply see, notice this is external. This is external. So if this is external, this is external, this is internal, and this is internal, and they're on a straight line. Once they're on a straight line, it should add up to 180. So what it means is that this is 55. Here should be 55 plus what will be 120. So this angle should be 125 degrees, so that it will add up. And if that is true, that means that since this is adjacent to, since this 55 is adjacent close to this, you do 180 minus 55 degrees will be equals to what? That will be this angle, and that's 125 degrees. So this angle should be 125 degrees. And notice again, if this is inside, internal should add up to 180 degrees. Internal angles on a straight line should be equals 180 degrees. So this should be 55 degrees. If you don't want to do it like that, you could have said this angle here, notice everything here is the same thing with here. So if this is 55 degrees, this should be 55 degrees. And notice everything here, is the same thing with everything here. So you can say corresponding angles. So correspondence. So it depends on how you want to look at it, but the main thing is you know the principles now. So that's how to go about it. In our next class, we do angles. Welcome to Academic Daddy's class. So today's class we are doing angles. In our next class, we'll do triangles. So we say that angle is a measure angle is a measure. So let me use angle instead of angles. Is a measure of rotation or turning. So when something turns or when something moves through a circular path, it creates an angle. That is why we say rotation or turning. So when you have two lines, so angle is also formed. Angle can also be formed when two or more lines meet. So we say that angle is formed when two or more lines meet. So see for example, so see what I mean. If I have turning or rotation now, something turns or rotates, notice that by the time I come and check this turning now, I can see that it's turned to this point. Let's say now we use a line to join, to mark out this. Now, should we see two lines meeting? So it gives us that the angle here is an acute, is less than 90. While if I have, for example, something like this, I can say, okay, let's say I maintain horizontal like this now. And let's say I have this. Let's say this is the turning point. To get the angle, I need to join. So a situation where I have, for this is still acute. So but a situation where I have, let's say, something of this nature, and I choose to now, let's say I have this here. So like what I'm trying to do with this is not like this is how angles, you get angles, but I'm just trying to show you the definition that whenever something turns, it means that it makes a point where two lines meet. That's just what I'm trying to say. So let's now take note of what we call kinds of angles. So the first one is acute. Okay, let me get that place. I wrote it. So acute angle. Okay. Anyway, let me just. I wanted it to be fast. So I said first, acute angle. So anything acute angle simply means angles less than 90. Once the angle is less than 90, So if this is 90 degrees, any angle less than it is called acute. The second type of angle is what we call obtuse angle. Obtuse angle. So any angle greater than 90 but less than 180 is called obtuse. So greater than 90, less than 180 degrees is called obtuse. Number 3, reflex angles. Any angle greater than 180 degrees, less than 360 degrees is called a reflex angle. And you need to know that the external angles of an acute and obtuse triangle gives a reflex angle. So see what I mean? If I know that this is acute angle, this is acute. Reflex, the external, that is the outside of this. Notice that from here now, watch from here now. If I do this thing now, this line is 180. From outside here, down, that is from this line, down to this place. So you see it passed 180 and moves on, but it did not complete a circle. So if I have obtuse now, this is obtuse angle greater than 90. It is greater than 90 or less than 180, does not form a straight line. So if I know it, if I start from down, see it cuts this. Now this is the point where you have straight line. It cuts it, so it's greater than 180. But notice it will move like this. It stops. So this is what you mean by reflex angle. So the mistake some students make is looking for reflex angle starting from inside. No, it is from outside. So this is how reflex angle is. So this is reflex angle. So the fourth one is what we call right angle. So right angle is simply angle that is equals to 90 degrees. So when vertical and horizontal line meet, it forms a perpendicular line, and that perpendicular line forms an angle which we call the right angle. And that means that anything that is perpendicular, represented like this, anything perpendicular means that is at 90 degrees. So if you say something is it forms a perpendicular, it means it forms a 90 degrees. So if I know that the fifth one is what we call point angle or complete angle. So complete angle, there are angles equals to 360 degrees. So for example, a circle, the angles equals to 360 degrees. So the next one, number 6, adjacent angles. So adjacent angles are angles close to each other. You see angles next to each other. So if I have, for example, this as an angle, now that means that there is also another angle here. So AB. So A plus B must equals to 180 degrees. So we see that they are adjacent angles. A is adjacent to B. And that means that A will be equals to 180 minus B. And B will be equals to 180 minus angle A. So note that. That's what adjacent angles means. So the next one, the next concept we'll apply is the concept of so, and every adjacent angle is a supplementary angle. So the concept of angle addition. So what this means is that whenever I have two or more angles that will give me 90 degrees, let's say I have, for example, I have this thing here now, and as I have it here, here is the other pen. This one is not same. Where are you? So let's say I have this now, and I have that this is 30 degrees. Automatically here will be 60 degrees. So why did I do that? Because if this is A and I don't know this, let's say I don't know this, it will simply be that A plus B will form this 90 degrees. And that means that A will be equals to 90 minus, okay, sorry, B will be equals to 90 minus A, and A is 30. B will be equals to 60 degrees. So when two angles add up to 90 degrees, we say they are complementary angles. This is for angle. This is how you represent angles. Complementary angles. While if I have, for example, I have A here and I have B to be equals to 50 degrees. This thing, if I do A plus B equals to 180 degrees, why? Straight line. Angles on a straight line equals to 180 degrees. Now this means A plus 50 degrees is equals to 180 degrees. It means that A will be equals to 180 degrees minus 50 degrees. This is equals to A is equals to 130 degrees. If you put 130 here, 130 plus 50. So this is what we will call the second one. This example is what you call supplementary angles. So supplementary angles. So we say that when two angles add up to 180 degrees, they are adjacent angles, adjacent or allied angles, and they are an adjacent and allied angles. They are supplementary angles. So now that you know this, you need to know that the third one, okay, I think we've written that. So you need to know that in order to identify angle, let's say I have this, and I have this, and I have this, and I have this, and let's say I have something here. In order to identify that the line I have here is the same, we always use something to show the difference. So let's say the angle here is the same with the angle here. I can use two arcs. And now let's show that the angle I have here and the angle I can use just one arc to show the difference. Let's say this is parallel to this. I can use two lines. I won't use the same because I've already used this one. I'll use two lines to show this. So you always indicate vertex 6, or you say you always indicate, let's say if this is A, say this is B, so B, whichever, but you always indicate so that there will be naming convention for what you are doing. Even this line, I'll come and name it. Maybe this is line A, line B, line C, line D. On this side, E, F, G, H. So you always put identifiers. Maybe here becomes Q, P, R, S. So if I know that, in our next class, okay, or maybe let's check if there is an example question. Okay, let's say I have this. Let's say I have this. And let's say they call here 120 degrees. Yeah? And then let's say now I have here to be 40 degrees. So let's say this is X. Let's say this is Y. And let's say this is Z. They tell me to find the missing angles. Let's say I have another one too that is like this. And here is 60 degrees. And maybe here, if this is 60 degrees, here should be 120 degrees. That is on a straight line if they are equal. Like, see what I mean? If this is going to make this to be 120 degrees to become 180, that means that it is one external 120 from what I taught in our first class. 120 plus 60 here will give us 180, and this 120 60 will give you 180. So it's not must you put all this. I'm just trying to teach you. So let's say this is example 1, this is example 2. They tell you find the missing angles here. So to find the missing angle, the easiest way is to remember that if I have an external angle on a triangle, external angle on a triangle is equal to the sum of the two opposite angles. This is for angles. But notice, if you do this thing like this, it's trying to say that the two opposite angles, like, or should I say the two sum of the angles, like opposite to opposite it. Notice the two opposite angles is this. But if this will confuse you saying it, all you just need to do is that as you've seen this now, notice that this is a straight line. You can just make this like this. So you see straight line. That means that Z plus 120 degrees will equals to 180 degrees, angles on a straight line. So Z will be equals to 180 minus 120 degrees. So that Z will be equals to 60 degrees. So once I get this thing to be 60 degrees, I can now say, okay, that means angles on a straight line, angles on in a triangle, angles in a triangle is equals to 180. That means that if it's equals to 180, I don't know y and I don't know x. But notice something. This angle here is the same angle here. They are alternate angles. So I can say that x will be equals to 40 degrees, alternate. So if that is the case, it simply then means that angles in a triangle will mean x plus y plus z should be equals to 180 degrees. So that x 40, y I don't know, z 60 degrees equals to 180 degrees. So that means that this will be y plus 100 equals to 180 degrees. So y will be equals to 180 degrees minus 100. So y will be equals to 80 degrees. So this is 80 degrees. Now notice something. 80 plus 40. 80 plus 40 is 120. You see that if you sum these two up, it gives you this external. So that is why we quote this rule. So now let's check this particular one here. Let's say we are asked to find, if we are asked to find in this case, let's say the angle here. In that case, they need to provide us with, should I say, something on this. They need to provide us with something like this because I need to know some part of this. So I think let's find a proper question than just getting questions from our head. So let's say we are given in our next class we're going to be doing triangle. So let's say we are given this. And I told you it's T. Then we now have something like this. And we are told here is 40 degrees. And we are told here is X. Told here is R. Here is U. Here is Q. Here is S. Then they now ask us to find, let's say here is Y. Tell us here is Y. Even without putting the sign. The angle I have here will be the same with the angle I have here because notice they are the same thing. That is, if I bring this thing like this, bring this part like this. See that this part, if I close this and close this, It's like this part is the same thing with this part. So that means that the angle here is the same thing here. So that means that y is equals to 40 degrees. So if y is equals to 40 degrees, I can now obey the same rule. Say, notice that this is 115. If this 115 touch this straight line here, it becomes 180 degrees. And 180 degrees minus 115 is equals to what? 65. That means that the angle here is 65 degrees. So I can easily see sum of angles in a triangle. So x plus y plus 65 equals to 180 degrees. So x, y, 65. So this will be x plus 40 plus 65 equals to 180 degrees. And this will be y equal y plus 105 equals to 180 degrees. So y is equals to 180 degrees minus 105 degrees. Y is equals to 75 degrees. Yeah. Is it y or x? Ah, good. X, sorry. X, sorry. X, sorry. X, sorry. So x will be equal to 75 degrees. And if you do 75 plus 40 is 115. So this plus this is equals to this. So the external angle made by a triangle is equals to the sum of the two opposite angles. So note that. So this is all about angles. In our next class, we will continue by going into triangles and then treating everything we need to know about that. Thank you. Subscribe to my channel.